Start recording. So we have started with the unit number 2, that is nothing but geodetic surveying in the previous lecture. Okay, so we have started what do you mean by geodetic surveying, how the classification has been done, what do you mean by triangulation, how the classification of the triangulation system has been done, that we have seen in the previous lecture. Okay, so now we'll move further. So now next point is nothing but triangulation figures. Okay, so correspondingly as per the systems, okay, so as we had seen that there is primary, secondary and tertiary system, triangulation system. So for that we are forming triangles. Okay, so what should be the size, that it has also been mentioned. Okay, that what will be the average triangle closure we have seen in this table. The previous scene. This yes. So in this table we are seeing correspondingly what should be the length of the baseline, length of side, actually error of base, what it should be. Okay, so that correspondingly they have been mentioned there. So now based upon that we are going to decide whether we should go. We are deciding the baseline. So depending upon that, which type of triangulation figure we should adopt. Okay, that we are going to here. Okay, so now correspondingly, this triangulation figure is a group of or system of triangles such that any figure has one side and only one common to each of the preceding and following figures. So correspondingly, these are the various types, that is single chain of triangles, second double chain of triangles, then braced quadrilaterals, then fourth central triangles or points and polygons, and fifth a combination of above systems. So we'll see one by one. So this is nothing but triangles. So each and every corner is nothing but, as I told you, this correspondingly these corners are called as triangulation stations. Okay, and this entire system is called as triangulation system or triangulation figure. Okay, so it can be triangle, it can be based on a quadrilateral, or it might be polygon with central station. Okay, so now we'll see one by one in detail. Okay, so this is single chain of triangles. So you can see here only correspondingly single chain is to be laid down here. Okay, so this figure, that is single chain of triangles figure, is used when a narrow strip of terrain is to be covered. Okay, though the system is rapid and economical, so it is not accurate for primary work since the number of conditions to be fulfilled in this figure adjustments are relatively small, and it is not possible to carry the solution of triangles though the figures by two independent roots. Okay, correspondingly there are many chances of errors that are likely to occur, as correspondingly you can see here number of stations are more, but as correspondingly baseline must be introduced frequently. So each and every, as we go further and further, we are requiring to consider the baseline. Okay, so that is regarding the single chain of triangles. Okay, next one is double chain of triangles. Okay, so you can see here. So as compared to single chains, the single chain was restricted to this much part only, but here you can see it can be used to cover a greater area. So as compared to single chain, it can cover a greater area, that is our larger width area. Third one is the braced quadrilaterals. So in this we can see correspondingly the in this correspondingly quadrilaterals are been formed. You can see here. Okay, so with four corner stations and observed diagonal forms. Okay, so correspondingly these are best suited for hilly countries. Okay, so since this computed lengths of the sides can be carried through the system by different combinations of sides and angles. Okay, so you can see a triangle here which is darkened, that is nothing but fixed station. So triangle, that is apexes of the triangles, are called as nothing but triangulation stations. Okay, and correspondingly, double line indicates the measured baseline, and AZ is nothing but fixed azimuth. Okay, so that is nothing but dealing with base quadrilaterals. Next one is central triangle and polygons. Okay, so these figures are also used to cover area. Okay, which give satisfactory results in flat countries. So where there the nature of the ground is flat one. So in that case, you can go for central figures. And this figure you can see it might be a quadrilateral, it might be pentagon, hexagon, or double centered figure. And correspondingly, you can get desired checks whenever required, just like what we take during the check leveling of any kind of survey. It's like that you can get desired checks for the calculation. Correspondingly, you can see that as the number of stations go on increasing, okay, here. So this corner, as I told you, that are nothing but triangulation stations. So number of triangulation stations are more. So corresponding the work is more, and due to which the work becomes slow as the number of stations are more. You can see here. Okay, so at each and every corner, you are supposed to set up the instrument and correspondingly measure the horizontal angle, measure the length, and move further. Okay, further. So that is regarding your triangulation layouts or triangulation layouts. Okay. So there is certain criteria. So by which you should go, whether to go for a single chain, double chain, centered figure, quadrilateral, best quadrilateral. Okay. So correspondingly, the figure which you are going to select should be such that at least one and preferably both roots should be well conditioned. So suppose I am going to take these central figures and I'm going to keep my instrument at this corner. Okay, I'm going to keep my point here. Okay, that is my instrument here. So it should be axial from both the sides. That is the condition. And correspondingly, all the lines in the figure should be of comparable length. So whatever is this length, suppose take a case of this. Okay, suppose whatever is the length of AB, it should be somewhat equal to AC. Okay, and correspondingly, if the distance is A to D and another is A to C only, okay, so it should be correspondingly neglected. Okay, so correspondingly, it should be avoided. So long distances should not be taken into consideration so that it becomes difficult for completing the work. And correspondingly, the figure should be such that least work may secure maximum progress. Okay, so you can go for double chain, so where you can start with the work easily. Okay, so that the more width of area you can cover it. And suppose if you're interested to measure the distance or the area beyond this line and beyond this line, just set up again a second baseline on the right hand side and on the left hand side. Okay, so that you can go on correspondingly measuring the area. Okay. So next, this was correspondingly triangulation layouts or triangulation figures. Okay. So you can see here primary triangulation for large countries, how the correspondingly systems are being utilized. Okay. So out of that, one is grid iron system, second one is central system. Okay. So you can see here the survey which has been the GTS survey is been carried out in the India. Okay, so this is nothing but in order to measure the overall area. So this was the chart. Okay, so correspondingly you can see here. Okay, how the best marked and how the area measurement is been done. So here also you can see that how the triangles are been formed. Okay, so that the area can be measured. Okay, so in detail some of the part. So as I told you that spotted corner or apexes of the triangles are called as triangulation stations. So you can see here, they are marked here. Next, okay. So that was regarding your triangulation figures. So next is the reconnaissance survey. Okay. So what do you mean by the reconnaissance survey? So reconnaissance survey is also known as your preliminary survey. Okay. So which is required to be carried out. Suppose area is to be told to be surveyed by you. Okay. So directly you cannot go with the modern equipments and start working with that and start measuring the area. Okay. So what you are going to do? First of all, you will visit the site. You will determine roughly. You will get a roughly idea that whether it is a flat slope or steep slope, how much is the area, how much is the slope, how much is the distance between first and second corner of the plot or the area. Okay, so you are going to do any kind of preliminary survey. That is nothing but your reconnaissance survey. So as I told you, you are not going to carry directly the instruments. Okay, that is modern equipment directly. You are not going to make use of the total station or DGPS. Okay, like that, which are costlier. Okay, so you can take a pocket tape. Okay, correspondingly small equipments, minor instruments. So in order to correspondingly measure the slope, okay, you can go with the prismatic compass. Okay, correspondingly you can have your small binoculars, so that suppose the area is a larger one, you can see through that. Okay, so that is nothing but your reconnaissance survey. So we'll see. So correspondingly, also we are mainly we are knowing that the principle of surveying, that is the basic principle of surveying, is nothing but working from whole to part. Okay, so correspondingly the following operations are required. So as I told you, you are going to examine the land. Okay, that is suppose countries to be surveyed. Okay, so in that case we are going to do the examination of the country to be surveyed. Next, selection of suitable sites for baselines. Okay, so whenever you are going to measure the land, okay, or the country, you are going to set up suitable baselines. So with respect to which you are going to measure the area. So with respect to the baseline, you are going to decide the figure whether it is a single chain, double chain, or it might be centered figure or quadrilateral based. Okay. So for that purpose, you are requiring to select the suitable sites for baselines. Then selection of suitable positions for triangulation stations. Okay. So now you have marked the baseline. Okay. So where the triangulation station should be marked. Okay. And as we are knowing that the long distances should be avoided. Okay. And the length of each and every side should be somewhat equal. Okay. So such conditions you should take into consideration. Then determine the whether the station points, that is triangulation station points, are intervisible from each other or not. Okay, and if there is any requirement that is a point supposed to be measured or which is to be visible from a naked eye, whether it is not visible, so in such a case you are going to erect a tower in that case. Okay, so that we are going to see detail in the part signals and towers. Okay, so that is nothing but determination of intervisibility and height of stations. Okay, so intervisibility means what? So suppose just take an example. So this is 1 minute. So this is the triangle. Okay, and these are the correspondingly our station points. Okay, that is triangulation station. So let I will know it as A, B, and C. So suppose the distance between AB is 12 kilometers, and this distance is 10 kilometers, and somewhat it is suppose 13 kilometers. Okay. So if I'm going to, if I can see the A point from B, okay, correspondingly the A point should be or B point should be visible from A, isn't it? So that is nothing but intervisibility. So take an example that our college is located at a higher elevation as compared to any other location so which is at the lower elevation. So you can see the points which are at the below location, but you cannot see, okay, that B point where it is located. So take an example, as I told you, our college is located at the higher elevation, okay, and Jyotiba, our hill is also located at the higher elevation. So we can directly see both the points, okay. But in between that, suppose if you are interested in locating a point, okay, here, so which is at a distance of 12 kilometers only, as I am marking. So this is suppose our college point, and suppose this is the CBS stand, okay. So CBS stand cannot be visible, but you can see our college, okay. So as it is at the higher elevation, okay, but as compared to A, it is at the lower elevation. So for that purpose, you are supposed to erect a tower, okay, and you are supposed to determine what is the height. So from which, from this point, the A point also can be visible, okay. That is nothing but you're determining the intervisibility and determining the height of stations. And you are supposed to collect certain miscellaneous data. That is nothing but whether there is a presence of water, food, labor, and local guides available or not. So if you are going to do the survey in a correspondingly forest part, so you should know that, because the person who is going to do that work, okay, so he should have correspondingly communication for food, water, okay, and if any required, so you can have a local guide, okay. Also correspondingly, you should take if existing map is there, okay, so with respect to that you can do the survey work, okay, and correspondingly it is been done on a very rough pattern type, okay, and for this purpose, as I told you, you can carry the various instruments, okay, like small theodolite or a small sextant for measurement of angles. So we have seen small box sextant is there, so by which we can measure the angles, or small theodolite, okay. Then next you can carry prismatic compass for measurement of bearings. Then steel tape or pocket tape you can have, okay. Then you can have binocular, okay. Then instruments and materials. Then guide ladders, ropes, etc. for climbing trees. So as I told you, directly you are not going to first of all construct the tower also, okay, for getting the intervisibility of the stations, that is of the triangulation stations. So for that purpose, basically you are going to use ladders, okay, or ropes in order to climb the trees, and so that you can see whether that point is visible or not from each another. Suppose A is visible, as I told you, but B is not visible. So in such a case, I will just suppose there is a presence of any tree. So the person will climb over the tree and check the visibility that A is visible from B position. So for that purpose, you are going to make use of this ladders, ropes. Okay. So this was nothing but the concept regarding the reconnaissance survey. So you are supposed to carry out for triangulation station or marking the baselines. Okay. 1 minute. So there are certain selection criteria, okay, for triangulation stations. Okay, just a minute. Okay. So as I told you, there are certain selection criteria, just like our when you are going to decide which figure you are going to choose. So there are certain criteria for selection of triangulation stations. So directly you cannot go with the selection of any position for the triangulation stations. So we'll see one by one. So first of all, the triangulation should be intervisible. Say okay. So for this purpose, they should be on highest ground, such as hilltops, housetops, etc. So as I told you, our college is located at the higher elevation, but the CBS is not located. Okay, as compared to that point. Okay. So for that purpose, correspondingly, the both the points should be intervisible from each other. Okay. So it should be located either at the hilltops. So as I told you, other example, that is college is at the hilltop. Correspondingly, our Jyotiba temple is located at also the hill. Okay, so directly you can have a intervisibility between them. Okay, so for that purpose, this triangulation station should be intervisible from each other. Next one, so the stations should be easily accessible with instruments. Okay, so whenever you are going to carry your instruments, okay, so directly you can go with the station instruments and place over the station points. Okay, so that is nothing but, and correspondingly it should be such that supplies of food and water is also available at that place, and camping ground or nearest suitable accommodation is available. That is also criteria for selection of triangulation stations. Okay, correspondingly the stations should be well conditioned, okay, or we can call it as well shaped triangles. So what do you mean by that? Correspondingly, the triangle should be either isosceles with base angles of about 56 degree, or equilateral, that we are going to see in detail for the, okay. So fourth point is nothing but stations should be so located that lengths of sites are neither too small nor too long. Okay, so as small sites cause error of bisection. Okay. Okay. I'm audible. Yeah. Yes. Okay. Just a minute. So we have seen that correspondingly the distance between the two triangulation stations should be not too long, or it should not be also too small, because the small sides cause errors of bisection and centering, and long sides to cause direction error as the signals become too indistinct for accurate bisection. Okay, and also for the purpose you are supposed to go with the direction of the tower. So that is also main part. Okay. Next criteria is nothing but the station should be at commanding position so as to serve as a control for subsidiary triangulation. Okay, and for possible extension of the main triangulation. Means what? So as I told you, if the length of one side of the triangle is 12 kilometers and second one is of 10 kilometers and other is 13. Okay, so both the stations should be in such a position that if I am interested in dividing from primary triangulation to secondary triangulation, okay, so that I can mark a second triangle in that, between that, that is subsidiary, I can go for the below triangulation system, that is from primary to secondary. And if I'm again interested from going from secondary triangulation system to tertiary, that will be okay for extension of my main triangulation. Okay, grazing line of sights should be avoided, and no line of sight should pass over the industrial areas to avoid irregular atmospheric refraction. So grazing line of sight means what? Correspondingly, if your line of sight, the points are intervisible, but you are having some kind of obstruction, that is grass is there, okay, or certain small bushes are there on the ground, and correspondingly which makes an obstruction for measuring the corresponding or becoming intervisibility of each of the station. And also the line of sight should, the line of sight should not pass over the industrial areas, because we are knowing that the atmospheric condition above the industrial area is a different one, and the condition of refraction we have seen. Okay, that is correction we are applying. Okay, that we have seen correction for curvature and refraction. Okay. So that is regarding our atmospheric refraction. So the line of sight should not pass over the said industrial areas. Okay, so these are the certain selection criteria for the triangulation station. Also, correspondingly, you should not take into consideration the whatever is the work you are going to carry out, if it is going to be taking place in the heavily wooden country. Okay, so in such a case, there are chances of correspondingly cutting down trees and clearing and correspondingly building of towers is required. So the overall the cost goes on increasing. Okay, so you should try to avoid in going for work in the wooden country. Okay, or you can just cut out some of the trees and make use of that for constructing the tower. That is also other part. So now next we'll see what is actually we were telling that intervisibility. Okay, so correspondingly, as I told you, visibility, that is nothing but intervisibility. Okay, visibility from both the points, that is nothing but intervisibility. So there are different cases. Okay, so the formula which we are derived or the value or formula which we were having for combined correction, okay, that is of the curvature and refraction. Same formula we are going to apply here. Okay, you can see here. So if the intervening ground, so case one is that intervisibility not obstructed by intervening ground. So if there is not any kind of obstruction between the 2 points, okay. So the distance of visible horizon from the station of known elevation is calculated from the formula, that is nothing but h is equal to d square upon 2r in bracket 1 minus 2m, where h is the height of the station above datum, capital D is the distance of visible horizon, and r is the mean radius of the earth. And this m value, okay, that is mean coefficient of refraction, which is taken as 0.07 for sites over land and 0.08 for sites over sea. Okay, that is the formula. So distance, if you are knowing what is the distance between the two station points, r earth's mean radius you are knowing, m factor you are knowing, that is either it is 0.07 for sites over land and corresponding 0.08 for sites over sea. So you can calculate what is the height correspondingly required in order to get the interval correspondingly of the station. Okay. Next, okay. So same formula further. After substituting the values of r, okay, here. So this formula we have seen 0.06735 d square. Okay. In the corresponding, yes, reply. Isn't it? We have seen or not? This h is equal to 0.06735 d square in the correction of combine and curvature in the unit number 1 itself of the surveying one. So just after substituting the value of the distance d, we were finding out the h1, that is height of the tower or height of the hill, so that they are intervisible from each other. Okay. So take an example. Okay, so such kind of sketch we have also drawn in the case of surveying one. So suppose this A is the point located here and B is the second point. Okay, and this is the point of tangency. Okay, so from where you can get the distance. So DA is the distance from this instrument up to A, and DB is the distance from the instrument up to the second point. And this is the total distance. So D is nothing but equal to DA plus DB. Okay, so directly by making of this formula, DA. Okay, so what you are going to do? You are going to just transfer this at the bottom and take the square root. So D will be equal to under root of h upon 0.06735. Okay, so which gives us the value equal to 3.853 under root HA. So in order to find out the distance between the instrument and the said correspondingly object, okay, or any station point, if you are knowing the height, okay, of that said object, you can find it out. Similarly, the distance dB also you can calculate. Okay, or total if your distance if you are knowing, then just by deducting it from dA which we have calculated here, you can calculate the distance dB. Okay. So for the known distance of visible horizon dB, the height of station B is calculated. Okay, so same condition here you can see. Okay, so that was regarding the condition of intervisibility of stations. Okay, so have you understood? Okay, so that was the thing about your starting point. Okay, so correspondingly, 1 minute.